So Mount Carbonyl, at the top are the higher energy species, at the bottom are the lower energy species. All these arrows are ways to go up and down the mountain, right, and change things. Acid chloride, right, is really reactive because this is a really good leaving group. So things you start to look for is what are good leaving groups on here, right? How can things be a good leaving group? How can things be stabilized with a negative charge or neutral? Halogens are electronegative. Anhydride, this is an anhydride. So if you look at this piece, this is a really good leaving group because it can do resonance, right? So acid chlorides, then comes acyl anhydrides are good leaving groups, right? Next down the mountain, we see our esters. Kind of crammed in here that I don't see them are the aldehydes above and then the ketones, right? Now we're just kind of doing the carboxylic acid derivatives. But if you wanted to put in aldehydes and ketones somewhere, they're kind of right here. Aldehydes are higher up than ketones, and then esters, right? Just look at the leaving groups, right? Look at the part that's attached there. This can do resonance, this cannot, right? Chlorine is a better leaving group than oxygen because chlorine can stabilize charge better, right? It's a better leaving group. If you keep going down, you get to an amide, right? This is not as good a leaving group as an ester, right? Because a nitrogen is not as electronegative as oxygen. All right? So these are rules we know, just applied in different ways. And then finally you get to the carboxylic acid. And why is the carboxylic acid at the bottom? Because guess what it is? It's an acid first. Hence the name. Right? So this H is going to be really prone to being reacted with any sort of nucleophile we add. Instead of the nucleophile going to this carbon of the carbonyl group, it's going to want to react as a base and take this hydrogen off. That's why it's at the bottom. So we're going to learn a lot of new ways to go up and down the mountain, right? So there are ways to go from the very unreactive all the way up to the very reactive, like SOCl2 can get us there, right? And there's plenty of ways to go down the mountain. It doesn't take very much energy to go down the mountain because you're going from a more reactive to less reactive species, right? But there are certainly ways to go reverse and up and down, right? Right. Good. So that's kind of the fun idea about Mount Carbonyl. Things at the top, things at the bottom. Look for the trends. Acid chloride, anhydride. Maybe you haven't seen those before, but you should know why they're more reactive. Halogen, resonance, then aldehyde ketone, ester, oxygen, versus an amide, nitrogen, electronegativity about leaving groups. And then finally, carboxylic acid at the bottom. It's carboxylic acid. So when I'm thinking about reactivity here, I'm talking about the carbon of the carbonyl group, right? The carbon of the carbonyl group. And the tricky thing with the carboxylic acid is it's electrophilic at this H as well. It's an acid, right? It's an acid. So that's usually the first thing that it reacts with.